joining the midpoints of two parallel chords passes through the center and is perpendicular to the two chords. We have to prove two things in this theorem. One is the line joining the midpoints of two parallel chords passes through the center. This is the first one. And the second one is the line joining the midpoint of two parallel chords is perpendicular to the two chords. We have to prove these two things. Well, to discuss this theorem, first of all, I'm going to discuss some basic points of geometry. Here you are seeing on your screen some key points. One is parallel lines. Number two, transversal, which you have learned from your +7 mathematics book. Point 3, mutual corresponding angles. Number 4, mutual alternate angles. 5, rectangle. 6, and the key point 6 is a theorem which is included in your +7's book. If two sides of a triangle are equal, the angle opposite to the equal sides are also equal. Well, let's explore one by one. We know what is parallel lines. I have taken two straight lines. We can call these two lines are parallel to each other only if the shortest distance between these two lines at all points equal. If the distance between these two lines, the shortest distance should be shortest. If the shortest distance between these two lines at every point is equal, then we can call these two lines are parallel to each other. And we know how to find the shortest distance. If we draw a perpendicular, this will be the shortest distance. That this is the perpendicular at that point and at that point. And here also. If the length of this perpendicular is equal to this one and also equal to this one, we can call these two lines are parallel to each other. Or there is another way to say two lines are parallel to each other. That is, if you draw a perpendicular to one line among these two. Suppose I am drawing a perpendicular on that point on that line. I am drawing perpendicular to this line, and if that line is also perpendicular to this line also, we can call this two lines are perpendicular. The precise way is the first one to say these two lines are parallel and this is the shortest distance at every point of the two lines. The shortest distance between the two lines at every point should be equal. If this line is equal to 5 meter, this one should also 5 meter, this one should also 5 meter, this one also should 5 meter, this one also, this one also, this one also. Every single shortest distance should be the equal. Only then we can call these two lines are parallel to each other. Well, now our second point is transversal. What is transversal? Suppose I have taken two lines, any two lines, and if I draw a line that goes through or passes through these two lines, we call this line a transversal. We call this line a transversal. We call this line that intersect these two lines, we call that line a transversal. Well, when a transversal intersect two lines, many angles are created in the diagram. One is here, another is here, one is here, one is here, one is here, one is here. Total 1, 2, 3, 4, 5, 7, 8 angles have been created. We won't discuss all of them since you have learned all of them in your class 7. We are going to discuss only mutual alternate angles. We are only going to discuss mutual alternate angles, and also that for parallel lines. If I try to discuss these points elaborately, this will consume a lot of time. I'm not going to do this since this is your last year's topic. I'm just going to give a recap of all the points. I'm taking two parallel straight lines. These two are parallel to each other, and there is a transversal that intersect both these lines. And we know that if a transversal intersect with two parallel lines, if a transversal intersect with two parallel lines, the mutual angles are equal to each other. The mutual angles are equal to each other. If a transversal intersect to a straight line, and that straight lines are also parallel to each other, these two lines should be parallel. These two straight lines should be parallel. Only then we can say that the alternate angles are equal to each other. So let's name this angle 1, let's name this angle 2, let's name this angle 3, and name this angle 4. So we can say angle 1 is equal to angle 3. This one is equal to the alternate angle 3, and this angle 2 is equal to the alternate angle 4. Hope you know this. alternate angle 1 is equal to the alternate angle 4. Alternate angle 2 is equal to alternate angle 4. Well, now you also know what is rectangle. You also know what is rectangle. If the opposite sides of a quadrilateral is equal and parallel to each other, then we call that quadrilateral a rectangle. We can call this quadrilateral a rectangle only if the opposite sides are equal. That means this one is equal to this one, and this side is equal to this side, and this side is parallel to this side, and this side is parallel to this side. Then we can call this quadrilateral a rectangle. And we also know that the four internal angles are 90 degrees each of them. This one is 90 degrees, this one is 90 degrees, this one is 90 degrees, and this one is also 90 degrees. And if we join the two opposite corners, we call that line diagonal. We call that line a diagonal. And always remember that a diagonal of a rectangle bisect the corner angle. That means this diagonal has divided this angle into two equal parts, this one and this one. Since the total angle is 90 degrees, so this should be 45 degrees and this should be 45 degrees. Similarly, this one also 45 degrees and this one also 45 degrees. And there is also remaining two opposite corners, and if we join these two corners also, we find another diagonal of the rectangle. This diagonal also divides this angle into two equal parts. This one is 45 degrees, this one is 45 degrees. Similarly, this one is also 45 and this one also 45 degrees. Since this one is 45, this one is 45, so we can say this angle is 90 degree. We can say this angle is 90 degree. Since the total internal angle of a triangle is equal to 180 degree. Since total internal angle of a triangle is 180 degree, so in this triangle, this is a triangle. In this triangle, this angle plus this angle is equal to 180 degree. This one is 45 degree, this one is 45 degree. So 90 degree is distributed in these two angles. So there we are remaining 90 degree within 180 degree in this angle, in this triangle, so this should be 90 degree. If I demonstrate this separately, this triangle is this one, and we have shown earlier this one is 45 degree, this one is 45 degree. Since the total internal angle, this one plus this one plus this one is 180 degree, and 45 degree is given in that angle, another 45 degree is given in that angle, so we remain only 90 degree. This one is 90 degree, so this one is 90 degree, this one also 90 degree, this one also 90 degree, this one also, and this one also. Hope you have diagram. I'm going to prove this for two different diagrams, since you are going to sit for exam where you have to face CQ type question, so your teacher may give any kind of diagram. So I'm going to prove this theorem by two diagrams so that you won't have to face any problem at the time of your exam time. First diagram I'm going to draw. This is our circle with center O, and we can take the two parallel chords by two different ways. We can take two parallel chords in two different ways. I am going to prove this theorem in two different ways. In first way, our two parallel chords will be on same side of the center. In our first way, we are going to prove this theorem where our two parallel chords will be on the same side of the center of that circle. Suppose our two chords, one is here, another is here, both of them are parallel to each other. Let's name it AB, and this one is CD. These two chords are parallel to each other. Remember, these two chords are parallel to each other, and see, these two chords are on the same side. These two chords are on the same side of the center. This one also downwards, this one also downwards. You can also take these two chords upwards, top of the center, the above of the center. That means I am trying to say that you can take these two chords in two different ways. You can take these two chords above of the center, you can take these two chords below the center, you can take these two chords at the right side of the center, you can take these two chords left side of the center. Well, now I'm going to find the midpoint of AB and also the midpoint of CD, and you know how to find that midpoint. So this one is the midpoint of AB, and this one is also the midpoint of CD. This one, let's name it P, is the midpoint of AB, and this one Q is the midpoint of CD. Now if I join these 2 points, if I join these 2 points with the center of the circle, we can apply the theorem 1 of chapter 10. First of all, I'm going to join the midpoint of CD, Q and O. I have joined 2 points O and Q. In our first theorem, we have learned that from our first theorem of 10 chapter, we know that if we join the midpoint and the center of a circle, the line segment is perpendicular. The line segment is perpendicular to the chord. That means this line segment is perpendicular to this chord. Now, if I raise this line segment downwards, if I raise this line segment downwards, and we are seeing that this line segment has intersect or hits the chord AB. Here's the chord AB. Here's the chord. Okay. First of all, what I have done? At first, I have drawn a perpendicular, not exactly perpendicular. I just join the 2 points, center and the midpoint of the circle of the chord CD. And according to our first theorem, this line segment has become a perpendicular to the chord CD. This one is 90 degree and this one also 90 degree. And I have raised this line segment downwards, and that line hits the chord AB at that point P. Now we have to prove that at first we have to prove that this line segment or this line has created an angle of 90 degree with AB. We have to prove that this angle is 90 degree. At first we have to prove that this angle is 90 degree. Well, if we can prove that this angle is 90 degree, we can easily prove the theorem. For this, you have to give your attention. I'm drawing the circle again. This is the center O. And this is a chord. Let's name it CD. And we are taking another chord that parallel to CD, and we name it A, B. These 2 chords, this one and this one, are parallel to each other. Suppose that, or if you divide this chord into 2 equal parts, we will find the midpoint of the chord CD. Suppose this one is the midpoint of CD. This one is the midpoint of CD. Suppose this one, name it N. Suppose N is the midpoint of CD. Now I'm going to join the 2 points O and N. I'm going to join the 2 points O and N. So the line segment that joining the 2 points, the center of the circle and the midpoint of the chord, that line segment will create an angle of 90 degree with the chord according to our first theorem. That means this one is 90 degree according to our first theorem. Well, now what we have to do, we have to raise this line segment. We have to raise this line segment downwards. Well, when I have raised this line segment downwards, we can clearly see that this line segment or this line has intersect with the line with the chord AB, and the intersect point is here. We have to prove that the angle between this line and this line is 90 degree. If we can do this, if we can prove that this angle is 90 degree, we can easily prove the theorem. Let's do it. Let's give an explanation of the diagram. Let ABDC be a circle with center O. AB and CD are two parallel chords. N is the midpoint. N is the midpoint of the chord CD. And is the midpoint of the chord CD. Let's name this point. Q, and I am changing this line a bit. And Q are the midpoint. And Q are the midpoints of the chords CD and AB respectively. We have to prove that the line segment and Q passes through the center of the circle and is also perpendicular to the both parallel chords. Well, this is our diagram. This is center O. This is our chords A, B and C, D. This one is the midpoint of CD. We named it by N. Okay, I'm going to prove this step by step. It may vary from your teacher's method or guidebook's method. First of all, I'm going to join O and N. First of all, I'm going to join the 2 points O and the midpoint N of CD. I have joined it. We can say okay, if we join the center, if we join the center O and the midpoint N of chord CD, we can say the line segment ON is perpendicular to the chord CD, according to our first theorem. So this angle is equal to 90 degree, and also this angle is also 90 degree. Now I'm going to raise this line segment. I'm going to raise this line segment downwards. Well, I'm raising this line segment downwards. So this line segment has intersect or hits the chord AB at that point. Let's name it Q. Let's name it Q. I have raised this line segment ON downwards, and that line, after that, that line hits the chord AB at Q. So let's say that now if we raise the line segment, downwards, the line will hit the chord AB at Q. So if I demonstrate these lines separately, this one our center O, this is our chord CD, this our chord AB. I am demonstrating these lines separately. I am not drawing the whole circle. We have earlier shown that, or we have taken these two chords in such a way that these two chords are parallel to each other. That means AB is parallel to CD. And we have also found or drawn a line, this one. I have drawn this here, this one. We named it N, and we also named this point Q. Since in our diagram this line is perpendicular, to the chord CD, so this one is 90 degree. So we can say that this one is 90 degree, this one is also 90 degree, and this one also 90 degree, and this one also 90 degree. Now here AB is parallel to CD. And OQ, this line segment, I'm naming it OQ. This line segment OQ, and OQ is the transversal. OQ is the transversal that intersect or hits the two chords. This one is the transversal in this diagram. Now, at the beginning of the class, I have discussed some points, some key points, and there we have shown the mutual alternate angle. Mutual alternate angle. This chord, this line and this line are parallel to each other, and this one is transversal. So we can say this angle is equal. This angle is equal to this alternate angle. This angle is equal to the mutual alternate angle. So this one is 90 degree. So this one also 90 degree. Similarly, this angle is mutual alternate to this angle. This angle is mutual alternate to this angle. So since these two chords are parallel, we know that the mutual alternate angles are equal when these two lines are parallel. So this one is 90 degree and this one is 90 degree. That means the line segment that we raise downwards, here's the chord AB, also create an angle of 90 degree, also creates an angle of 90 degree with the chord AB. Now back to our main diagram. That means this one is also 90 degree. This one is also 90 degree. So if we write this logically, AB is parallel to CD and OQ is the transversal. So we can say angle C and this point is N, C and Q is equal to angle BQN, BQN, or you can say BQO, since this line is the same. BQO, you can say BQN or BQO, all are same. I'm writing BQO. In third parenthesis I am writing mutual alternate angle. Now since C and Q is equal to BQO is equal to C and Q, the value of C, angle C and Q is 90 degree. So this one also 90 degree, this one also 90 degree, such that that means OQ, OQ is perpendicular. This is the symbol of perpendicular. OQ is perpendicular to the chord AB. Since this one is 90 degree, so this chord is perpendicular to chord. This line segment is perpendicular to the chord AB. Well, back to our main diagram. This one is 90 degree. This one is 90 degree. Now the line that create 90 degree with chord AB is from the center O. This line is from O. That means center of the circle. This line is from the center of circle. And we know that if we draw a perpendicular, let me write it down. If we draw a perpendicular to a chord from the center, the perpendicular will hit the chord at its midpoint. If we draw a perpendicular to a chord from the center, the perpendicular will hit the chord at its midpoint. See, we have proved that this angle is 90 degrees. That means this line creates an angle of 90 degrees with the chord AB. That means we have drawn a perpendicular to AB from the center O. So by this line, or by this one is also a theorem. This statement is also a theorem. So by this theorem we can say that this point is the midpoint. This point is the midpoint of AB. So we can say Q is the midpoint of AB. If you check carefully, we have already proved the theorem. See, this line segment, this line is going through the midpoint of CD. This line also going through the midpoint AB. So we have joined, since this line segment is going through the midpoint Q and N, so we can say that we have joined the two midpoints Q and N. And this line also passing through the center. See, this line also passing through the center. So we can easily say that if we join two midpoints of two parallel chords, the line will pass through the center. And during our whole time, during the time of proving this theorem, we have also proved that this line joining the midpoint, that going through the center, is creating an angle of 90 degrees with the chord AB, and also creating an angle of 90 degrees with the chord CD. So if you see the statement, prove that the line joining the midpoints of two parallel chords passes through the center. We have already proved that passes through the center and is perpendicular to the two chords, and we have also proved that one. So finally we can say, so the line joining the midpoints of two parallel chords passes through the center, and is perpendicular and is also perpendicular to the both chords, and we have proved this theorem. This method may vary from your usual method. I don't know how your guidebook has proved this theorem or your teacher proved this theorem. I don't know. I always try to follow my own style. I always try to prove this in a different style so that you can impress your teacher by your own methods, by your different style from others, and this will help your teacher to show an extra affection towards you, which is very important. Hope you will understand this whole process very easily, and this is our first way to prove this theorem. If you want, I can prove this theorem in another way, and I will prove this only if you want. Otherwise, I'm going to skip this way. If you want, message me. I will show that method in different way in our next class. Till then, goodbye.